So let's give a formal definition here. An improper integral with an infinite bound, and here bound means where you start or stop rather than an upper bound on the overall value or a lower bound, for example. So what we just did, we had an infinite upper end, right? We said don't stop till you get to infinity, but we had a finite starting point. We just use 0, but it could be anything. It could be 1, it could be 10, it could be 2, it could be negative 20. It doesn't really matter. So the way we're going to formally define this is say, if you see an integral that's going to infinity here, what you can think of is that it's kind of stopping at b, giving you an answer based on a and b, but then you let b go to infinity and see what the formula gives you. So what did we saw? What did we see? We saw 1 minus e to the minus b, right? We put in like 1 and 10 and 100, and that was the upper end of the integral. And then if we ask what's the limit as b goes to infinity of that thing, you could write that as 1 minus e to the minus infinity, but that's not really a proper way to write things. That's kind of an improper way to write things, but it kind of gives the sense of what's going on. And we said that was basically 1 minus 0, which was 1. And because the limit existed, that is, it was a finite number, not infinity or negative infinity, and it didn't oscillate without settling down, those are the two main ways that an integral to infinity can fail to exist, or a limit to infinity. Because this limit existed, we say that the integral converges, or it is a convergent integral. So the limit exists, it's finite and not oscillating without settling down. We say the integral is convergent, or the integral converges. And if that fails to happen, we say the integral is divergent, or the integral diverges. So now that we've got some terminology, let's try another one. How about the integral from 1 to infinity 1 over x squared dx? So go ahead and try to figure out, does that integral converge or diverge? If the integral converges, what is it equal to? In our previous problem, the integral was equal to 1. Okay, so pause the video, work on that, come back and see what you think. A good first thing to do is to graph it. So we're starting here at 1. 1 over 1 squared is 1, and this is falling off like that. So we're asking about that area all the way out to infinity. What's the antiderivative? Well, to take the antiderivative of 1 over x squared, I would want to write it as x to the negative 2 dx. That makes it easier to use the power rule. So we should say this is our integrand here. So what do we get there? You add 1 to the power, so you get x to the negative 1 over the power we just wrote. From 1 to b, we're substituting the b there for infinity, and we could put the word limit here. The limit is as b goes to infinity. And plug stuff in, you get negative b to the negative 1 minus 1 to the negative 1. And we're taking the limit of that. As b goes to infinity. So what do we get? We can move all this negative stuff around, and we get 1 minus the limit of b going to infinity 1 over b. And can we write that in any kind of simple way? Well, we could say, if you kind of plug in the infinity for b, we could say 1 over infinity, like that. We aren't really supposed to write that, so we'll put quote marks around it to kind of scare ourselves from believing it too much. And what is the limit of 1 over b as b goes to infinity? That was on our common limit sheet, except we called it x instead of b. You're basically saying what's 1 over 10, 1 over 100, 1 over a million, 1 over a trillion, 1 over a quadrillion. Those are getting to be really, really small decimals, right? And in the long run, that's just 0. So overall, it's 1. So the value of this integral from 1 all the way to infinity is 1. Would you say the integral is convergent or divergent? It's convergent, and the value of the integral is 1. And it wouldn't be a bad idea to draw the derivative or the antiderivative we got. Starting at 1 here, it increases and levels out and has a horizontal asymptote of 1. All right, let's try another one. How about the integral of from 1 to infinity of 1 over square root of x dx? Funny thing about this, when you draw it, it looks almost exactly like that if you draw it by eye. If you draw them both on the same graph, you can tell the difference. But just by eye, it looks basically the same. So go ahead and do this integral and see what you get. All right, so you might want to rewrite it as a power. This would be x to the negative half. And then once you take the antiderivative, what power do you get? Let's also say, remember, we're taking the limit as b goes to infinity. It'll be x to the 0.5, because we add 1 to negative 0.5, we get positive 0.5. 1 over 0.5 from 1 to b. And then what? We could say this is the limit as b goes to infinity of 1 over 0.5, b to the 0.5 minus 1 to the 0.5. And what is that? Well, we could move this multiplier up front. Limit of b to the 0.5 minus 1. And let's see, b goes to infinity. So that's 1 over 0.5. What is the limit of x to the 0.5 as x goes to infinity? X to the 0.5 is just square root. So you're going to get just larger and larger numbers. So you're going to get an infinity here, minus 1. And does this integral converge or diverge? Well, subtracting 1 from infinity, not going to change it. Dividing by 0.5 will double it, still infinity. So we get infinity. So this is a divergent integral. Oh, up here I meant to write capital F. So you could say divergent integral, or the integral diverges. Now, it kind of seems like, well, we wrote a number here, but when the limit is infinity, that counts as does not exist. And when the limit does not exist, we say the integral is divergent, either because stuff grew to infinity or because stuff oscillated without settling down. So this is a divergent integral since the limit was infinity, which counts as d and e. D and e being does not exist. It wouldn't be a bad idea to draw the function. We know it starts here at 1, and it's basically square root with the little modification. So this is going off like that, and that's our capital F.